Hey guys, it's your boy Daisuke. Today we'll be talking about bisected chord theorem.
So tell me, Curly, what is a bisected chord theorem?
That's a good question, Anya. To answer your question, bisected chord theorem refers to one of the relationships between chords and arcs. It states that if a radius bisects a chord, then the radius and the chord are perpendicular, meaning they intersect.
In a simpler version, imagine we have a circle with a chord, AB, and a line passing through the chord from the center of the circle. The sign will be OC, where O is the center of the circle and it intersects the chord AB at midpoint D.
According to the theorem, AD and DB are equal in length. If they are equal, it means they are congruent. So now Anya, why don't you show us an example?
Oh, sure. Now let's try to solve bisected chord theorem using geometry. Let's have our example in here. In circle 0, the radius OC is perpendicular to the chord AB at point D. If AD is equals 5x minus 12 centimeters, DB equals 3x plus 2 centimeters, and OD equals 4x minus 3 centimeters, what is the measure of OM? So as you can see, we're going to be adding our AD and DB. We should find the x of our AD and DB. So our AD is 5x minus 12, DB 3x plus 2. So what we're going to do here is we're going to find our x by arranging them. So 5x minus 12 is equals to 3x plus 2. So now we're going to be transposing 3x. So 5x is now negative 5x minus 3x equals positive 12 plus 2. So now we're going to be adding those up. 5x minus 3 is equals to 2x equals 14. And now what we're going to do here is we are going to be dividing 2x and 14 by 2 because of our 2x. So 2x divided by 2 is equals to x, and 14 divided by 2 is equals to 7. So our x is 7. So now let's go back to our 5x minus 12 and 3x plus 2. So since our x is 7, so it's now 7 or times 7 minus 12. 5 times 7 is equals to 35 and minus 12. 35 minus 12 is equals to 23. 3, 7 plus 2. 3 times 7 is equals to 21 plus 2. And if we add those up, it's now 23. And just like we said, the length AD and DB are equal lengths, or we can call them congruent. So since our AD and DB have the same centimeters, it means they're congruent and have the same lengths. And now let's solve for our OD. So our OD is 4x minus 3. So now since our x is 7 again, so 4 times 7 minus 3. 4 times 7 is equals to 28 minus 3, that will be 25. Now our next step So now, The question is, what is the measure of OM? Sorry, I think I meant OC. The question, what is the measure of OC? First step is we're going to be finding our OB. Because OB, the distance of OB is the same distance as OC. So, we're going to be using Pythagorean theorem. So our step or our formula is OD squared plus DB squared is equals to OB squared, which is 25 squared plus 23 squared is equals to OB squared. So 25 squared is 625, 23 squared is equals to 529 equals OB squared. So we're gonna add those up. 625 plus 529 is equals to 154. Now, to remove the squared in OV, we're gonna be using radicals. So 1154 and OB and so we're going to cancel the squared in OB, and so our final answer is 33.97. So our OB now is 33.97. So since our OB is the same measurement as OC, so OC is 33.97 as well. And that's our final answer for this example.
So in conclusion, the bisected chord theorem tells us that if a radius bisects a chord, then the radius and the chord are perpendicular. The two segments of the chords are congruent.
This property is helpful solving circle geometry problems, especially in situations involving tangents, angles, or arc lengths.
Polly says, "We hope this tutorial has informed you well on the bisected chord theorem."
And this is the Tulpar crew signing out.